Hello there, welcome to today's lesson. Okay, so I'm going to go over fractional equations today, and then radical equations, and then systems of three linear equations. First of all, let's start with this. The teacher is saying, "Where's your homework?" Me, "I lost it fighting some kid who said you weren't the best teacher in school." Yeah, that would probably be the only excuse that would work well for you. All right, this lesson is interesting because it starts out straight away with an example. These are the GIFs that I ended up going with. Do you remember what movie that's from? I think you do. All right, but I'm going to put him up out of the way. And basically it starts out with an example. And the first concept is fractional equations, and it basically says that a good first step in the solution of a fractional equation is to multiply the numerator in each term of both sides of the equation by the least common multiple of the denominators. So do you remember how to find the least common multiple? I'll show you how to do it, and then you'll have to do it in your homework. So that's what this first part of the lesson is about. It'll make these equations with fractions in it a lot easier, because what you're going to do when you multiply everything by the least common multiple of the denominator is you're going to eliminate all of the denominators, and then you don't have fractions, and it's going to be easier to solve. Okay, so if we're solving this equation, I'm going to erase this right here. The only thing that you have to be aware of is that x cannot be equal to -2. Why not? Because look here. That would make, if x was -2, that would make this 0, and you can't divide anything by 0 because, as you know, the world explodes. So we have to kind of remember in our minds that x is not going to be equal to -2. It can't be. Okay, now we're going to multiply each numerator by the least common multiple, which is going to be 21x plus 2. And that's just, you get that by multiplying these together. That's the least common multiple of these numbers, but then you also have to include that fraction in order to get rid of everything. So I'm just going to spread this out a little bit, and I'm going to multiply this first term by 21x plus 2, the second term by 21x plus 2. Okay, so when I do that, I'm going to end up with, let's do this first term first. Okay, look, we can simplify here. We can take this and simplify, because 7 goes into 21 3 times, and that makes that a 3. So it's basically 4 times 3 times x plus 2. So that would just be 12x plus 2. Let's do the second term. All right, on the second term, we can simplify here by canceling out the x plus 2's. That's going to eliminate that. So then it's just 3 times 21, 63. Okay, and then let's do the last term. What can we cancel out to make it easy? 21 over 3 is going to be the same as 7 on the top. So it's just 7 times 5. So it's going to be 35 times x plus 2. Okay, and then we just do this the way you do your regular math problem. So just multiply this out, 12 times x and then 12 times 2. So let's go ahead and do that. So 12x plus 24 plus 63 is equal to 35x plus 70. Okay, and then we just add all of these numbers that we can. We're going to add the 24, the 63 on this side, and then we're going to simplify all of this. If you do all of that, I won't go through it because I know you know how to do that. You get this. Divide both sides by 23. And x is equal to 17 over 23. And that's your final answer. So it's basically just the idea of, if you multiply a complicated equation with fractions by the LCM, you can get rid of all those denominators. Okay. Simplify, man, right? All right, let's go on to the next example. It's example 6.2. And this is the concept of adding these equations together. Okay, this is just what we learned. Let's get rid of these fractions by multiplying this whole equation by 35. That's the least common multiple of the 7 and the 5. The y is actually supposed to be up there. Okay, so let's multiply everything by 35. And then 35 here, and then 35 there. And then what about the bottom equation? Did you know you can do the same thing with decimals? Because decimals are just basically the same as fractions, right? So let's multiply everything here by 100. So 100 times that, 100 times that, and then 100 times that. And that will actually get rid of the decimals. When we do the top, do equation A, and this simplifies, because 7 times 5, so it's just going to be 5 times 3. The next one's going to simplify because it's just going to be 7 on the top, 7 times 2, that's a plus sign. All right, so it's going to be, A is going to be 15x plus 14y is equal to 385. I just did 11 times 35. And then B is going to be 100 times all these numbers, so we just move the decimal. So it's going to be 3x minus 20y equals negative 37. And now you've got two things that you can work with here. And then the idea is to make one of these variables disappear, right? So we're going to try and make the x disappear. And in order to make the x disappear, we keep this top one the same, we just multiply it by 1. We change the bottom one, so we multiply it by negative 5. So if we change b and multiply everything by negative 5, whoops, I made it look like an x, but I don't. I just want to multiply it by negative 5. Negative 5 there, and times negative 5. I don't like how that looks because it makes it confusing because there's another x there. So that changes that bottom equation to negative 15x plus 100y equals 185. Now I can go through and erase all of this. And now I've got two equations I can totally work with. Let's add them together. When we do that, the x's cancel out, right? And we got 14y plus 100y, 570, divide by 114. And then y is equal to that fraction, and you can simplify it or put it in your calculator, and it's 5. And that's solved. Then you want to find the x, right? So then you take that 5, which is the y, and then you can plug it into any one of these equations. So instead of that y, we're going to put 5 there, and then we just solve for x. And you know how to do that already. If you do that, you get 21. If you don't know how to do it, ask me, but I think you know how to do it. All right, now let's talk about radical equations, or any equation that has one of those radical signs in it. So you can do the same thing here as you can in other equations where you try and get rid of that radical sign. So what you have to do to get rid of that radical sign is to step 1, isolate the radical. And then step 2 is to raise both sides of the equation to the power that gets rid of the radical. I know that doesn't make a lot of sense until we actually do it. I know, hope you don't look like that, but we're going to actually try it. Let's do example 6.3. If we got an equation that looks like this, we want to get rid of this guy to make it a little easier. Step 1 is to isolate the radical. That means put it on one side of the equation by itself. So let's get rid of that too. Now we have x minus 5, but it's the cubed root, is equal to 4. Now that we have it to this point, then we can multiply raise both sides to the third power. It has to be the third power because this is the cubed root. If that was a square, then we would square everything. But we have to raise everything to the third power. So what does that mean? It means this is raised to the third power, this is raised to the third power. When you do that, that cancels this out, right? So on that side, all we have is that. And now this is super easy to solve. X minus 5 is equal to 4 times 4 times 4, which is 64. Add 5 to both sides, and then you are left with x is equal to 69. That's the final answer. So easy, right? Easy. You've got this. You're feeling good now, right? Not crying anymore. Okay, you can always go back and check your answer, plug that answer in, and make sure that you get the right one. Okay, here we go. We're going to go on with the next example, which is this one, and we are going to solve for s. First, we want to isolate this on one side of the equation. We're going to isolate the big one with the lots of stuff underneath it, okay? Even moving this to the other side, that's okay. We're just going to isolate one of them. Whoops, I didn't mean to do that. All right, so let's start doing that. We're going to just rearrange so that it says we're going to subtract minus square root s from both sides. And then I'm just going to erase that. Okay, so this is how the equation looks now. And then once we get to this point, we're going to square both sides of the equation. We're just going to square everything. So when we do that, here's the tricky part. So you're going to have to watch this carefully. Square this, okay, and square this like that. Okay, make sure that you square it that way. Because that you don't want to square each one individually, you want to square both sides. That's how it works. Okay, so on the left-hand side, it's going to be easy because the square cancels out this. So that's going to be easy. On the right-hand side, it's going to be not quite so easy, but, you know, just as easy. So when you square that, what you're actually doing is you are doing this. 8 minus square root s. You're making this happen twice. So it's this times this. And you remember when you multiply out something like that, you have to do first, outside, inside, and then last. You have to FOIL it out. So it's not a super easy thing to do. So let's just FOIL it out and see what we get. If you FOIL it out, 8 times 8 is 64. Plus outside is going to be this 8 times square root s, and then it's going to be minus 8 square root s. That's the same as on the inside, minus 8 square root s. And then at the end, it's just going to be plus s. Why is it plus s? Because we've got the square root s times square root s, and it just simplifies to this. And then we can simplify this part to just minus 16s, minus 16 square root s. Did you see how I did all of that? Okay, I think you know how to do that already, so I'm just going to do it that way. Okay, now we're going to do that again. We're going to rearrange the whole equation again to isolate this all by itself. First, let's get rid of those s's. Did you know you could minus s, so you get rid of it on both sides. Whoops, that's still going to be negative 48. Okay, so that's what we're simplified to. And now we're going to get this square root s on by itself. Okay, so to do that, minus 64 here, minus 64. Let's see, minus 112 equals negative 16 square root s. Let's divide both sides by 16. Okay, so square root s is going to be equal to 112 divided by 16, which is actually 7. Okay, and then we just square both sides of the equation, right? Just do it again, just square it. Square this, and when you square it, this cancels this out, and you've got s is equal to 7 squared, which is 49. Final answer. All right, you can plug that back in if you want to check your math without getting out the book. Plug that back into where these S's are and make sure you get something that equals something else. All right, now we have done systems of 2 linear equations, but what about 3 linear equations? So you can solve these using either the substitution method, meaning you solve something for x and then plug that thing in to one of the other ones, that's the substitution method, or the elimination method where you add a couple of them together to try and eliminate one of the variables. So when you've got 3 equations, you're probably going to end up using both of those things. And this book is designed so that the numbers are, the math will work out, so you'll usually end up with integers when you do that. Okay, so what do we do with this equation? The easiest thing to do is to solve, we're going to solve C for x, because that is just going to be x is equal to 2y. See how I added 2y to both sides of the equations? Okay, so that's going to be the easiest there. Now when I have x is equal to 2y, I can take that x and I can plug it in to A and I can plug it into B right there. So let's go ahead and do that. The A equation is going to end up being 2 times 2y plus 2y minus z equals 14. That can simplify to 4y plus 2y. 4y plus 2y can simplify again to 6y minus z is equal to 14. Now, what happens when we plug this into B? Okay, you will get 3 times 2y plus 3y plus z equals 16. This simplifies to 6y, and that simplifies again to 9y. Now I've got 2 equations where I can use the elimination method because I've got a negative z here and a positive z here. So if I add these equations together, these are going to just cancel out. So 6y and 9y is going to be 15y. That z goes away, is equal to 30, and then I've got y is equal to 2. Okay, now that I've got y equals 2, I can start getting all my other answers. So I can take that 2, I can plug it in here. If I do that, I will figure out that x is equal to 4. And then once I have x and y, I can plug it into any one of these and figure out what z is. And if you get the answer right, you will get 4 and 2 and negative 2. I don't think I need to do it because I think you know how to do it from there. Let's just do this very last example. That's a funny gif of Malcolm, remember? When he's trying to bowl. All right, and we're going to do that again. The first thing we're going to do is we're going to eliminate z. Why are we going to eliminate z? Because it's all by itself, and if we just add a couple of those together, then we can get a new equation where we eliminate z. So let's just move equation C out of the way for a little bit. I'm going to add these 2 equations together. The negative z and the positive z cancel out, so I'm just going to write nothing there and just add them. So starting over here, we have x plus 2x is going to be 3x plus 1y. So just y equals 4. We're going to take this equation, we're going to put it aside. Now we've got that equation. We're going to bring this other equation back. And we're going to do the same thing, except now the equation that we're ignoring is this equation. Sorry, my thing is being weird. The equation we're going to ignore is this one, and we're going to add these other 2. So if we add these two, 2x plus 2x is going to be 4x. Negative 2y minus y is going to be minus 3y. The z's cancel out, and that's going to equal 1. Okay. Whew. Now I've got two new equations with just x's and y's. Just put that there. Okay, now how can we eliminate one of these? Now we look at these and think, how can we eliminate one of these? And if we multiply this top equation, if we multiply everything by 3, we can get rid of it. So that equation would end up being 9x plus 3y is equal to 12. If we add these, we get 9x plus 4x is 13x. These cancel out, equals 13. X is equal to 13 divided by 13, which is 1. Okay, now that you know one of them, you can find all of them. Just plug the 1 in. Plug it into, let's plug x into this equation right here. If we do that, we get 9 times 1 is equal, wait, let's do that again. 9 times 1 plus 3y is equal to 12. Subtract 9. 3y is equal to 3. Y is equal to 3 over 3, which is 1. Okay, and then you can find z from there. It's easy. Okay, that's all. That's all for today. Thanks, Addie. Bye.